Okay, we're going to do this next lesson, which is called one-step equations. You're actually solving for x. In that whole entire section, we never really solved for x before on that test. We just simplified things. We just multiplied things. We just substituted in for things. We never really solved for x or for a variable, and that's what we're going to do today. So let's start off with a couple really easy things. I'm just making these up off the top of my head. So x plus 3 equals, 7. Let's do that. So what are we trying to do here? And they'll say solve. I'll tell you what it says to do. It says solve each equation or just solve. Trying to find what x is equal to. So we're trying to find a number. If I add 3 to it, I'm going to get the answer 7. Everybody understand what we're doing here? Okay, so I got to figure out what is this. Now you could just sit and guess a whole bunch of numbers and see what works, but there's a better way to do that. And that way is to get rid of everything that's with the x. I want to isolate the x, is what math teachers say, or I just want to get x by itself. All right, that's what I'm trying to do. I'm trying to get the x by itself. Now I've got this equal sign. So think of the equal sign as being on the left side and the right side of the equal sign. So if I say on the left side, I'm talking about the left side of the equal sign. If I say on the right side, I'm talking about the right side of the equal sign. So we kind of split it. It's not necessarily in half, but we split it so we have a left and a right side. Okay, let's get to it. Well, that's what I'm trying to teach. So what I'm trying to do is I'm going to try to get x by itself on one side. It could be the left side, it could be the right side. It really doesn't make any difference. Okay, now there's some times where it's easier to keep it on one side than the other. And in this situation, we want to keep it on the left side. It's already on the left side. It's positive, right? There's times when it might be a negative. But if it's positive, I would just keep it on the side that it's on. All right, if it was over here on the right-hand side, I would keep it on the right-hand side if it was positive. If it was negative, I'd move it to the other side. We'll get to that in a second. All right, this is about the easiest. I can't think of any easier solving for x kind of problem than this would be right here. So let's watch. So I'm trying to get the x by itself. Well, what's with the x? What's on the same side with the x?
3.
Okay, it's not just a 3. It's a plus 3. It's a positive 3. So I want to try to get rid of that positive 3 because that'll get x all by itself. So I want to get rid of the 3. So what we learn in algebra is that to get rid of something, we always do the opposite of what's being done to it. So what's being done to this 3? It's a positive 3. It's a plus 3. So what is the opposite of adding a 3? We subtract it. That gets rid of it. Okay, we always do the opposite. So if you get rid of this, we get rid of it by subtracting. Now we got to keep it balanced. So if you do something to the left side, you also have to do it to the right side. So if I subtract a 3 from the left side, I can't just do that and then continue. I've got to also do this to the other side. So if I subtract a 3 from this side, I also subtract a 3 from the other side. All right, it just keeps it in balance. All right, so they still will equal each other. Both sides will be the same. So look right here. Why did we subtract a 3 from a positive 3 to get rid of it? Because what happens? They do what? Okay, but what happens to the plus 3 and the minus 3? Okay, we say they cancel out, but right. And you've heard me all year say this stuff, but they add up to 0 is what they do. Okay, we could say they cancel out. I'm okay after a while that you say they cancel out. But I want you to know why they cancel out. They cancel out because they add up to 0. And x plus 0 is just what? It's just x. All right, now we bring down the equal sign, and then we do the thing on the right-hand side. Very simple. It's just 7 minus 3, which is 4. And then that's my answer. I circle it. You could always check to see if you got it right. So let's do it. Let's put this 4 back in for the x to see if this is really the number that works. Okay, so you put a 4 in for the x. And then what do? I add a 3. Does that equal 7? Sure, 7 equals 7. It checks. It works. So I'm confident that that's the right answer. All right, pretty simple. What if I had something like this? We'll keep the 7 there. What if I had this? Same idea. I want to get the x by itself. So I have to get rid of this 3 right here. But what is this 3 doing to the x? It's being subtracted, isn't it? Okay, so again, how do we get rid of something? We always do the Opposite. What's the opposite of subtracting? It's adding. So this time I'm going to add a 3 to both sides, right? Because that way these will add up to 0. But I can't just do it to the left side. Talk to me. I have to do it to the other side as well. Do the exact same thing. Because it keeps it balanced. It keeps that equation balanced. All right, so let's see what happens. What's negative 3 plus 3? Well, that's 0. What's x plus 0 or x minus 0? It doesn't make any difference. It's just an x. Or you could say they do what? They cancel out. All right, but I want you to know why they cancel out. Over here, what do we do here? This is a 7 plus a 3, so that gives you a 10. Circle it. All right, let's just check. Actually, before you even circle it, you could check if you wanted to. I'm not going to make you check these, but to be confident that you get these right, I would throw it back in and see if it works. Put the 10 back in for the x. So that's 10 minus 3. Is 10 minus 3 the same as 7? Of course it is. So we circle it, and we're good to go. Everybody with me?
Yeah.
Let's do another one. What if I had 3x equals 15? Take a look at this. Now, it's not being added. This 3 is not being added to the x. This 3 is not being added to the x. What's that 3 doing to this x right there? It's being multiplied. When there's no sign in between, it means they're being multiplied times each other. Sometimes you could see it like this, all right? But there's really no reason for the parentheses. So most of the time, you wouldn't see it like that. You would see it just like this. It's 3 times. So how do we get rid of the 3? We want the x to stay there on that side. So how do we get rid of that 3? We divide because we always do the what? The opposite. What's the opposite of multiplication? Is division. Now, I'm not going to do the division like this, okay? That's kind of old-fashioned. It's kind of elementary, middle school kind of ways to do division. When we do algebra, most of the time, not all the time, but most of the time, we would get rid of it by dividing, and we show dividing like this. It kind of looks like a fraction, but fractions are division. That's what a fraction is. You have a question?
3 points each is correction.
3. Yeah. All right, so I divided here. So if I do that to the left side, I have to do the same thing over here on the right side. So I divided this by 3, divided this by 3. Now watch what happens. They do cancel out, but do they cancel out for the same reason as what we just finished doing? Do they add up to 0? Well done. No, they don't. But what do? Remember, this is a division problem. It's 3 divided by 3. What's 3 divided by 3? It's a 1. And what is that 1 doing to the x? It's multiplying. So it's 1 times x, which is just x. So the 3's go away, don't they? All right? Or we say they do what? They cancel out, okay? But again, they cancel out for 2 completely different reasons. One, they added up to 0. This one, they divided to be a 1. That's why they cancel out. Over here, what do we do here? It's a division problem. 15 divided by 3. 15 divided by 3 is 5. Circle it. You're good to go. If you wanted to, we don't have to, but I'm going to show it anyway. If you wanted to, you could take that 5, replace it, that x with that 5, and let's see if it actually works. So this is 3 times x. We just said it was 5. That's what? 15. Does 15 equal 15? Yes, it does. So can I be confident that that's right?
Yeah.
Absolutely. Right with me? Okay, what if I had something like this? Now, I don't know if they put this on the worksheet or not. Yeah, they do. Good. All right, what if you had x divided by 3 equals, we'll just say 5 this time. Everybody watching? Okay. I want to get x by itself, don't I? So what do I want to get rid of? What's on the same side with the x? The 3 is. But this time, this 3 is not being multiplied. It's not being added. It's not being subtracted. What is that 3 doing to the x? It's being divided. That's right. So how do we get rid of something that's being divided? We multiply. Okay, we get rid of it by doing the opposite operation. Okay, so if it's being divided, we get rid of it by multiplying. So this is probably the one that's the trickiest out of the 4 that we're going to do here. All right, but it's really not that hard if you understand what you're doing. So watch. So I'm going to multiply by a 3. So watch how I do that. I'm going to put a 3 over 1. Is that all right? Since this is a fraction, I'm going to write this as if it was a fraction as well. So 3 over 1. Now, I multiplied the left side by 3. What am I going to have to do to the right side? Multiply that by 3 as well. So watch what happens. I got a 3 on the top and a 3 on the bottom. They're being divided, aren't they? What's 3 divided by 3? It's a 1. What's 1 times x? No, 1 times x is x. 1 times x is x. So really, what happened to that 3 on the top and that 3 on the bottom? They cancel out. And we can say they cancel out. I'm okay with that, as long as you know why they cancel out. All right? They cancel out because they divide to be a 1. 1 times x is x. The right side, I just do the multiplication. That's 15. That's my answer right there. You could always plug it in and check. So let's do it. You don't have to check these, but if on a test, you got some time, you might as well, just to see if you really did it right. So let's put that 15 in for the x. So what is that? 15 over 3. What's 15 over 3? It's 5, isn't it? So is 5 equal to 5? Of course it is. So we can be rest assured that that is the correct answer. Unless you checked it wrong, okay? But if you checked it right, then that is the correct answer. Let me see what else we have. All right, let's do this. What if I have negative 3x equals 7? Write that down. Are you writing this down? You taking notes on this stuff? Should be. So write it down. This is a little bit different for a couple reasons. First of all, everything we did over there, I handpicked these problems so everything came out to a nice whole number. Everybody see that? And everything came out positive. So I couldn't have picked easier things to do. It's not always going to be that easy. You know that, right? So what if you had something like this? Well, we want to get x by itself. So how do we get x by itself? We have to get rid of what? The negative 3. You have to get rid of the negative 3. What's that negative 3 doing to that x? It's being multiplied. So how do we get rid of something that's being multiplied? We divide. And we divide by a negative 3. Because we're trying to get rid of the negative as well. Everybody see that? Okay, so I got to get rid of the negative 3. It's very important. Now, if I do that to the left side, I have to come over here and do that to the right side. What happens here? Negative over negative is positive. 3 over 3 is 1. 1 times x is x. So this cancels out with that. Now, what do we do here? This doesn't come out even, right? 7's not divisible by 3, so you just leave it. Okay, now watch this. See how I have the negative in the denominator? It's perfectly fine. I could keep it in the denominator if I wanted to. But most of the time, everybody's listening, right? Not everybody. Most of the time, we don't usually put a negative in the denominator. Here's probably the best way you'll see in a math book or something like that. A math teacher will do this. You could put the negative right out in front and just put 7 over 3. That's one way to write it. And this would be fine. If I circled that 7 over negative 3, it's perfectly fine. I give you full credit for it. No big deal. But if you want it to look like the answer key or a book, you know, the answer in the book, most of the time they'll put the negative out in front. There's another way they could write it as well. What's another way they could write negative 7/3? Put the negative where? You could put it on the, well, it's in the middle right here. On the top, that's right. So negative 7 divided by positive 3 is the same exact thing as positive 7 divided by negative 3. Because what's a positive divided by a negative? What's any positive divided by a negative? What kind of answer, what kind of sign would you get? You'd always get a negative, right? Different signs, remember that? Some of you didn't, because I looked on the test and you did not do that. I got a negative times a negative, and people are putting negative for an answer. Negative times negative is positive. If you have two different signs and you're multiplying, the answer is always negative. Doesn't matter which one's the bigger one. You got to get your rules down. So you could write either one of these as an answer, okay? This is probably, my guess is, I would say that's the preferred way to write it, with the negative out in front, but it doesn't make any difference. And I don't have to do anything to this. In algebra, I mean, there are some times we do this, but for the most part in algebra, we will not take an improper fraction and turn it into a mixed number. Now, if you were working in the real world and you're a carpenter and you're trying to find the length of something and you do some math, you get an improper fraction, I would say 100% of the time you're going to change it to a mixed number. All right, so you get 3 feet and whatever inches or whatever the case is. Or in this case, it would be 2 feet and what, 2/3 or 0.6 inches, okay? Or 1/3, I'm sorry. Okay, so yeah, in real life you would do that. But in a high school math class, for the most part, unless they tell you otherwise, just keep it improper as long as it's simplified. As long as it's simplified. Let's do this. What if I said negative 3x equals negative 15? What if I ask you to do that? Well, the same step, right? Because it's negative 3x just like that other problem is. So I divide by negative 3, come over here, divide this by negative 3. This cancels with this, x equals. Now you got to simplify this. You cannot keep this. I will not allow you to keep this 15 over 3. All right, you have to simplify it. Apparently a lot of elementary teachers say that turning this into a mixed number, do you know what the mixed number for this would be? 1/3. How about 2? 2 and 1/3, right? Because that's 6 and 1 is 7. Okay, so it's 2 and 1/3. A lot of elementary teachers would make you turn it from improper to a mixed number, all right? But when you're in algebra, keeping it improper is fine. But, so this is really not simplifying. It really isn't. Okay, it's changing the form of it, but it's really not simplifying. This right here, though, you must reduce it. Okay, I'm going to make you reduce it. If you don't reduce it, I'm going to mark it wrong. So, first of all, what's negative divided by negative? It's always a positive. What's 15 divided by 3? It's a 5, so it's positive 5. So you must have that for an answer if I give you something like that. Does that make sense?
Yes.
Okay. I'm looking at your, okay, here's a situation. What if I had 3 equals negative x minus 2? Same kind of thing, a little trickier than what we've done before, because look where the x is. The x isn't on the left-hand side. We're so used to having the variable on the left-hand side, aren't we? Okay, but this time it's on the right-hand side. Now, you got a couple options here. You could say, well, let's just keep the x here. Let's do that. I'll do both options for you, okay? So you could just keep the negative x over here on the right-hand side and get rid of the minus 2. How would we get rid of that minus 2? Add a 2. I'll show you both ways, and you can decide which way you want to do it. I really don't have a preference, to tell you the truth, as far as the way you do it. So what happens here? That cancels, adds up to 0. Bring this down. 3 plus 2 is 5 equals what? It's negative x. So is my answer 5? Well, it will be. I'll show you why. Everybody watch. I'll show you why. You could just look at it and say, if this is negative, let's just change that to positive. So I change the sign of this, change the sign of that. But technically, this is what you're doing. This is a negative 1, isn't it? Negative 1x. So it's being multiplied, isn't it? So how do I get rid of something that's being multiplied? Divide it by negative 1. So what do I do over here? Divide that by negative 1. So 5 is equal to what? Positive x. Or if you want to, I'm a little OCD. I like to always end up my problem having the x on the left-hand side like this.
Isn't it negative 5?
Yes, of course it is. It's 5 divided by negative 1 is negative 5. Thank you. All right, because different signs are always negative when you divide or multiply. Okay, so that's your answer right there. If you wanted to leave it like this, that would be okay, I guess. To me, that just looks a little weird, don't you think?
Yeah.
I just like that. It looks a lot better. Let's do another one. Let's do, I don't know. Again, I'm just making these up off the top of my head. What if you had this? It's really not much different than what we've done before. Divide by negative 7, correct. So divide by negative 7. How did you know to divide? Well, it's not because there's an x, because the negative 7 is being multiplied by the x. So you always do the opposite. The opposite of multiplication is division. So I come over here and do what? Divide by a negative 7. So if it was me, I wouldn't keep the x over here. I've already got it by itself. So I'm just going to say x equals. Now again, here's another one. You've got a negative on the bottom, so I could just keep it 5 over negative 7. That's perfectly fine. Or I could write what? The negative right out front and put it like this. Or I could write it negative 5 over positive 7. Any of these are perfectly acceptable. Okay, my personal preference, and I wouldn't mark it wrong on a test or a quiz, but my personal preference is writing it like that. Either one of these, tell you the truth. I would rarely put the negative on the bottom, but it's fine. You can do that if you want. No problem. I'd still mark it right. Boom. Give you a nice little check mark. Isn't that nice when you see a bunch of check marks on your test? Yep. And I like doing it. I love sitting there and just going check, 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 check. Wish I could do that with everybody's. But no, I got to end up putting what? X's, X's, all right? I hate writing X's, okay? I like writing checks. So get correct answers so I can write a check mark on them, all right? Okay, that's it. So our homework is worksheet number 7. I'm just gonna number them. I was thinking about calling it like 1 1 1 2 and then 2 1 2 2, but I'm just gonna continue the numbers. So it's worksheet number 7 is your homework. Okay, it is the front and the back, and I'll give it to you right now. So make sure you get one. Don't leave before you get your worksheet.